we're going to look at a wordy practice on Mr Bosgras fireworks. Now, before we read any of this stuff, and you really should read all this, but before you do, we're going to look at how we can set up our equations. So we've got all this information. We've got an example of an equation down here. We're not going to use that next. And you should, of course, read the task. Here's the task, the first part. How many of each type of firework should we make? That's probably going to be the achieved question, the unique solution, probably. But once again, not even going to look at any of this, because first we have to make up the equations, and that's the new part. There's no equations here, really. So we're going to set up our equations. This is the information we're going to have to use. We just have to figure out how do we use it. So I like to start with this grid. We're going to make a grid like this, and I encourage you to make a grid on a bit of paper and work through this with me. So we're going to set up our equations as per normal. X's, Y's, Z's all lined up, and we're also going to have our totals listed here. And in fact, we're not going to start with these X, Y's and Z's. We're going to leave them. We'll come to them soon, but first, the beginning part will be listing all the totals. If you do this, it'll help you decide what your X, Y, Z's are, because we've got two choices. It could be these bits. It could be X, Y, Z as Einstein, Galileo, and Newton. Could be that. The other option is we could have barium, magnesium, and potassium as our X, Y, and Z variables. How much of each of those do we have? So because we could see that our totals given were for barium 405, 170 magnesium, and 2430 for potassium, and we'll label them. It's very good to label them. Helps us remember what we're talking about, in particular for X, Y, and Z. And we know that we've got these three as our totals. We know now that these cannot be our X, Y, and Z values. We've eliminated them as our possible options. That means that our X, Y, and Z values will be the other set of things that could have been our variables. So we know it's not barium, magnesium, or potassium. It must be these ones, Einstein, Galileo, and Newton. So that's what our X, Y, and Z will be. We know that because we put our totals first. So we can look at this and we can say each Einstein, Galileo, and Newton contains this much of barium, so it depends on how many of each we use. So X will be the Einstein, Y will be Galileo, Z will be Newton. So how much barium goes into an Einstein firework? So each Einstein firework contains 6 grams. In fact, this will be not how much goes into it, but how many of these, what number of Einstein fireworks should we make? We know that if we had 1, it would make 6 grams of barium. If we had 2, well, we'd need 2 times that, so 12 grams, and 3 be 3 times 6, and so on. So however many we have, we're going to multiply it by 6. So 6 grams for every Einstein firework. Every Galileo firework will contain 1 gram, so that would be 1 gram times the number Y of Galileo fireworks, and 9 grams of barium for every Newton firework, so that would be 9 times Z. So there we go, 6x, 1y, 9z, 405 is the total. So here we go. We said we weren't going to use it, but we can check. 6x, 1y, 9z equals 405. So that's an example equation that we had made just to show us that we're doing it right, but we didn't need that. We knew we were doing it right. So the same thing here, 4 grams of magnesium and 36 grams of potassium. That's all the X values there. That shows you how much of each goes into one Einstein firework. Same thing for Newton and potassium. So Newton and potassium, that's what the grid tells us. We're looking for Newton and potassium 54Z. Right, so you can just pick a square and use the row and the column to identify what that square represents. And now we'll just finish it off. 2 grams of magnesium, and we'll do the same for Galileo. 5 grams of magnesium and 24 grams of potassium. And that's your grid finished. So now we can just go and write these out. 6x plus 1y Okay, and now we're done. We've got our three equations. You can just put them straight in your calculator. You normally would have, or solve them algebraically, just like we would have at any other point in the topic. Just a quick note, we know that each of these is a plus. How do we know if it was a minus? Well, it would be at -9 in front of the z in our grid. So unless it says so, then we know that it's going to be a plus because it's a +9z, +9 grams for every newton. And that's that.